So 88-year-old female walking with a cane, 5 feet 6 inches tall and 160 pounds. All right, so you see here symmetry looks pretty good, obviously at 98%, which is that's the length of time they spend in contact with the ground. And you look here and you can see that their strides are also um, quite similar between the right and the left. So they spend about the same amount of time, through each one of those cycles. A little bit longer on the left. We'll look down here in a second. Speed 0.9 miles per hour. As we talked about before, so an average person, average adult of average age will walk at 3.0 miles an hour when we instruct them to, walk with intent as though they need to get from point A to point B. It does decline with age, so we don't have as much of a statistic, and it's a natural decline with age without necessarily pathology. But it shows here that she's only walking at 0.9 miles per hour, which is indicative that she is a slow walker. And again, why? Depends. They could be in pain. It could be because they have a fear of falling. And we'll look at that in a second. You indicated this was an older adult female that does use a cane to walk. Her cadence is also relatively slow in comparison to that speed. And then when we look at the walking cycle, it's in average, a 60-40 split between 60% in the contact and 40% in the swing phase. You can see with her, she spends about 70% of the time in stance phase. So she spends much more time in contact with the ground, which again is very typical for someone who might have a fear of falling because they're more stable when they're in contact with the ground than they are when they're in their swing phase. Also look at the double support phase is at 20%, and they're even more stable when they're in double support phase, so spending a lot of time in that phase, which again, why they're walking relatively slow. When you look at the gait line here, I'd rather see, this stay over here a little bit longer, so you can see that she transitions pretty quickly and spends most of her time in that foot flat. Again, why? Because you've got more feet in contact with the ground, so it's a more stable position, but it probably indicates that she's getting into a little bit more pronation a little bit sooner than later. And in fact, on this right foot, you see here that she's heel striking with a fairly neutral foot, which we'll probably see in the pronation supination. Her propulsion rate relative to how fast she's moving, it's normal, and that happens quite a bit in people that walk relatively slow. And it's because they are not, challenging themselves, and so it's easy to be much more consistent relative to that. Because propulsion rate is actually it's a ratio between the hip flexors and the plantar flexors, and so it's showing that she's fairly normal. Pronation supination angle, so you can see that she's almost twice in a normal position here, and that's actually more normal than it is here at negative 4.9 degrees. And so, as I mentioned earlier, you could tell that in this right foot, she does seem to be heel striking in a relatively neutral position. And then as she's moving through, she does transition, and then eventually she does actually go into a relatively pronated position, right? So she's really kind of turning that heel out. So if upon visual inspection, you might see that this patient is pronating and not knowing her entire history, wondering if possibly she also might have some diabetic issues and potentially any knee problems such as osteoarthritis. Can't really say that here, but I would just be, take that into consideration when you're looking at this, watching her foot profile as she goes through that phase.